Hey guys, this is Mrs. Keith, and today we're going to do notes over inscribed angles. So the important thing for you to know is that an inscribed angle is an angle whose vertex is going to lie on the circle. So in this case right here, this is the vertex of this angle, and it lies on the circle, so it's inscribed. And how you're going to get the measure of inscribed angles is to note that the sides that form that angle, these are the parts that form the angle. Whatever part of the circle that lies between those two sides, this part right here is the part of the circle that's between the sides of the angle. The actual angle, let's say it's 10 degrees, the part of the circle that lies between the sides of the angle is going to be twice as big, so this would be 20 degrees. Something for you to think about. Let me see if I can go to a chalkboard. That's silly how it shows all my markings are already done. Let's say you have a circle right here, and let's talk about the angle we just did. That was 10 degrees, so that part of the circle that lies between the sides of the angle is twice as big, so it's 20 degrees. If you have a central angle that's drawn at the center of the circle, remember we talked about that a while back, it's going to equal that intercepted arc, so that's 20. So the central angle equals the arc measure. The inscribed angle is half as big as the arc measure. Okay, the next important thing is that if you have an inscribed angle, which I do have that right here, if it's drawn to a diameter, which this is the diameter, so here's the sides of the angle, and they are drawn where they intercept a diameter. And remember, a diameter just cuts a circle into two equal parts. So this is 180 degrees for the arc measure from A to C. That angle B is going to be half as big, so it's a 90-degree angle. Okay, another thing for you to notice is if you have two angles, like this angle right here, and this angle over here. I don't know if you can hear my dog snoring, but that's what that noise is in the background. And if you have two angles that are intercepting the same arc, so they're both drawn to this arc right here, those angles are going to be equal to each other because they're both half as big as that intercepted arc that they're drawn to. Another important thing is if you have a quadrilateral that's inscribed in a circle. And what that means is that all the corners of the quadrilateral actually lie on the circle. If that's the case, then opposite angles are going to be supplementary. And so let's just think about how that works. If you've got this angle right here, it's drawn to this arc right here, so it's going to be half as big as that arc. If you have this inscribed angle right here that's across from it, or opposite of it, it's drawn to this arc. You end up using the whole circle, which is 360 degrees. So these opposite angles, this one and this one, they're going to be supplementary because they should be half as big as those intercepted arcs. So that means they'll add up to be 180 degrees. All right, let's do some actual examples. Okay, on this first example, we're trying to find angle STR. Well, STR is drawn here and here, so it's going to be half as big as this intercepted arc. So STR is half as big as 106, so it should be 53 degrees. Angle QRS, let me erase all of this right here. QRS is this angle right here. Oh, I'm sorry, I just drew that wrong. My bad. Angle QRS is actually this angle right here. R is the middle letter, so that should be your vertex. It's actually drawn where it's intercepting this diameter right here. And so it's going to be a 90-degree angle because on the other side of that angle from here to here is half the circle, which is 180 degrees, and that inscribed angle should be half as big as that. Okay, now let's do arc TQ, this arc right here. Well, again, this was the diameter, so it's half as big as a circle. So that makes all of this right here 180 degrees. I see that I've got this inscribed angle right here that's 65 degrees, and it's drawn to this part of the circle right here. So that should be twice as big. That makes this part of the circle 130 degrees, which makes this 50, so that the two will add up to be 180 degrees. So this is 50 degrees. Okay. I'm going to mark some of this back on here. I just found out that this was 50, and we talked about how this was 130. All right, now let's do angle SQR. SQR is drawn to this intercepted arc, the 106, so it should be half as big as that, so it's 53 degrees. And then we've already figured out arc ST is the 130 degrees. And then this last arc is arc QR right here. Well, remember all the arcs inside the circle add up to be 360. So I'm going to do 360 minus 130 minus 50 minus 106 to get this arc measure here, and I get that it's 74 degrees. All right, the next one, again, we've got an inscribed angle because its vertex is on the circle. So the angle should be half as big as the part of the circle that lies between the sides of that angle. So if this angle is 71, then this arc measure has to be 142. So that's the equation I can set up. 16x minus 2 equals 142. And now I can solve it. So adding 2 to both sides, I get 16x equals 144. And when I divide by 16, I get that x equals 9. And it's asking me to solve for x, so I've solved that problem. Okay, on the next one, an inscribed angle, I know that because its vertex is on the circle. So 2 of those angles should equal the part of the circle that lies between the sides of that angle. So again, this is the sides of the angle. The part of the circle that lies between the sides is right there. So 2 of those inscribed angles should equal that intercepted arc. So now I have an equation set up that I can solve. I'll distribute the 2. And then I end up getting x equals 17. Okay, this problem is actually asking me to find the measure of arc EC. So the measure of arc EC will be 5 times that 17 minus 27, which is 58 degrees when you actually solve it. All right, on the next one, we have a quadrilateral that's inscribed inside of a circle. All of its corners actually fall on the circle. So that means that these opposite angles, angle W right here and angle Y right here, they're going to be supplementary. So that means that 11x minus 29 plus 6x plus 5 has to equal 180 degrees. All right, solving that, I get 17x minus 24 equals 180. So 17x equals 204, which makes x equal to 12. All right, plugging that back in, I get that angle W equals 11 times 12 minus 29, which is 103 degrees. All right, so those are some quick examples that we have on our notes page. We have an extra in-class practice that I'm going to do a video for as well. All right, see you there.